Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to this channel, please do like and subscribe. Your efforts are massively appreciated. So today we are going to talk about another missing values technique. Previously we talked about CCA, that is complete case analysis, and saw the Python implementation. So if you haven't watched that video, go ahead and watch it. So today we have this technique known as 3M, or you can say mean median mode technique. So first we are going to talk about what this technique is, then we will talk about where we can use it, and finally we will talk about disadvantages and advantages of this technique. So let's go through what this technique is. So as the name suggests, this technique uses mean median mode for the missing values treatment. And when we hear about mean median mode, we may get this impression what's great in that. This is the first thing we learn in statistics. So this technique must be an easy one. But that is not the case. These techniques require a thorough understanding on some of the concepts in statistics. And the obvious one is mean median mode, or you can say measure of central tendency. Then there are concepts like normal distribution, skewed distribution, which we will try to cover as much as possible in this video. And the good thing is that this technique is suitable for both the categorical and numerical variables. Here we are assuming that the missing values are going to behave same as the observation at hand, because mean median mode is calculated on these observations. So in short, if I try to go into more technical terms, we are assuming that the missing value distribution is same as the observations we have. Next thing we have is when to use mean median mode, and it entirely depends upon the kind of data we are dealing with, which we will see in the later part of the video. So here I have prepared a table which is telling us when to use which statistics. And don't worry, you don't need to memorize this table. You will able to understand it once you go through the whole video. So let's understand this table first. So as you know, we have four kinds of variable. So first we have numerical variable. In that we have continuous variable. So if we try to understand it with an example, you can consider variable as BMI. So people have BMI like 17.5, 25.96, and so on and so forth. Then we have numerical discrete variables. An example can be number of glasses in a box. Like you cannot have number of glasses in a box 126.5 or 137.5. Either it has to be 125 or 126. Then we have categorical variables like gender, color of hair, etc. And finally, we have date time variables where we have date as a value. And the best example is date of birth of a person. Now talking about which technique we can use. In case of numerical continuous variable, here we can use all the three statistics. And why this is the case? We will talk about this in upcoming slides. And in case of discrete variable, we have to be very careful. Sometimes we can use all the three of them and sometimes we cannot. For example, we have a review variable in which it takes values like 1, 2, 3 up till 5. So it's kind of a discrete variable. Now if we take mean or median, chances are that we may end up getting values like 1.5 or 3.5, etc., which is continuous in nature. So this might can create a problem in training. But the mode is something we can always use. Now coming to the categorical variable, these are generally qualitative features, that is giving the quality of an object, like color of a car, color of hair. So in this case, we cannot compute mean or median, hence we have to use mode. Now talking about date time objects, here we cannot use all these three because these are really tough to deal with. So the best way to deal with them is to convert them into dates by using some other date time object variables. And then we can decide which statistics to use. And if you want to know how to do that, I have a project in which I have done the similar thing. And you can find that project in the I button. Now let's talk about mean, and this is going to be a quick review since I'm assuming that most of us already know this thing. So mean is also known as arithmetic mean, or sometimes we call it average. So it has mainly two properties for which it is famous. The first one is that algebraic sum of deviation from average or arithmetic mean is zero. That is, we have center point of the given data. Next is the sum of square of deviations is always minimum. So in short, we are trying to say that out of all the statistics available, the variance is least in case of mean. One thing good about the mean is it is least fluctuated by the sampling. So for example, if we take student ages and compute the average for each sample, then all the averages will be closer to each other. One thing bad about average or mean is it is affected by extreme values, or you can say that it is affected by outliers. And the formula for mean is sum of all the observation divided by the number of observation. And here we have an example of cricketer score in an ODI. And here if we try to calculate the average, we get 41.2. And one thing I want to highlight here is when we do not have much evidence, in that case, average is our best prediction. So if I were to ask you how much run this player will make in the next ODI, then your answer should be 41.2 because this is going to be the closest to actual score. Now the next question that we must ask ourselves is when to use the mean. And obviously we know that we have to use it in case of continuous variable. But as I earlier said, things are not as simple as that. We have to be very careful. So the answer to this question is when the data follows normal distribution, in that case we can use average. Although we can use all the three statistics like average, mean, median. So let's see what is normal distribution. So it's a continuous probability distribution and it is symmetric about the mean or average. That is the area to the left or area to the right of the mean are mirror image of each other. So it can be divided into two equal parts. Normal distribution is sometimes called as a bell-shaped curve, and obviously the name comes from the fact that it looks like bell, and we can see that in the image as well. It's a unimodal in nature, that is it has single mode and the mean median mode are equals. That's why we can use any of the statistics while filling the missing values. But in the real world, we don't get a variable that is perfectly normally distributed. It is going to be very close to the normal distribution. Or in my case, I have never seen a variable that is perfectly normally distributed. That's why we should use average. Then there is a constant proportion of population lying under the curve between the mean and a specific number of standard deviation. It means that the population under one standard deviation below the mean is equals to the population one standard above the mean. And in many books and blogs, you will see something like mean plus minus one standard deviation containing 68.2% of the population, and so on and so forth, which you can see in the picture as well. The skewness is 0 and kurtosis is 3 for the normal distribution. So that's the brief about normal distribution. So just to reiterate the point, that first we have to check the variable distribution, and if it's follow normal distribution, we should go with the mean. So let's see an example as well. This example is very straightforward, and in the practical section we will try to implement on the actual data as well. So here we have three variables, age, height and weight, and all of them have missing values. So we calculate the mean for each variable and then we simply impute them in the missing value places. And here I'm assuming that data follows normal distribution, but in reality when we are applying this technique, we will have to check whether it follows normal distribution or not. Next we are going to talk about median. So what is median? So the value that divides the data into two equal parts, that is the number of observation above median and the number of observation below median is equal. It is also known as position based average. It is very easy to calculate and sometimes we can just locate it by seeing the observation. And obviously this is only when we have few observation or data points. For our case, we cannot locate it by seeing. In case of even number of observation, we cannot determine the median exactly. It is estimated by taking the average of two middle observation, and I will talk about it more in detail. Median is very much affected by the sampling, but it is not affected by outliers or extreme values. Now let's take an example, and this is the same example we saw previously. So to find the mean, first we have to arrange the data in ascending or descending order. Then we simply take the middle term, and in this case the middle term is 50. So this is the case when we have odd number of observation because we have a middle term here. Next we see for the even number of data points. Again the process is similar. First we have to arrange the data in ascending or descending order. Then we have to take a middle term. But in this case, we have to take two middle terms. So here 50 and 55 are two middle terms. And then we simply take the average of these two terms, which is 52.5. So in this case, you can see that we do not have any concrete median. We had to calculate it using averages. Now the next question is when to use median. So when the data is highly skewed, in that case we go with median because median is not affected by outliers or the extreme values. So now let's understand what is skewed distribution. These distribution looks very similar to normal distribution, but they are asymmetric in nature. That is, the two halves are not mirror image of each other. And in the picture we can see three images. The first one is left skewed or negatively skewed distribution. That is because there is a long tail in the negative direction on the number line. And the mean is also on the left side of the peak. And here the median is greater than mean and mode is greater than median. Then we have normal distribution in the middle, which we have talked about previously. Next we have right skewed or positively skewed distribution, and that is because there is a long tail in the positive direction on the number line. And the mean is also on the right side of the peak. And here median is greater than mode and mean is greater than median. The skewness in case of skewed distribution is not zero, and this is because due to the presence of extreme values or outliers. The kurtosis will not be 3. So now let's understand it using the same data. So here we have calculated the median for each variable. And also while calculating the mean or median, we do not consider the missing values as the observation. So that's all for the skewed distribution. Now let me reiterate this point. That is, first we have to check the distribution of the data. And if it is skewed, we use median. Next we are going to talk about mode. So mode is defined as the value that has the maximum frequency in our data. In other words, it is the value that is predominant in our data set. So a data can be unimodal or having single mode, or it can be multimodal, that is having more than two modes. Mode is very easy to understand and calculate. It is not affected by the outliers in the data. It is not capable of further mathematical treatment. For example, in case of mean, you can further use it for finding the standard error or variation in the data. But that is not the case with the mode. Another problem with the mode is that it ignores a major chunk of the data while focusing on the most frequent values, which is not the case with mean or median. Now when we use mode, it is mostly used in case of qualitative or categorical data like gender or country in which a person is living. So how to calculate the mode? We just have to look for the value which has maximum occurrence in the data set. So we can see this example of parking lot, and here we see that red cars appear most. So in this case the red is going to be the mode. And here is the simple example of mode being implemented on a data. So here we have a color variable where we see some none values or empty values, and we have used mode. In this case the mode is going to be blue, and we have replaced these values with the blue. So whenever we are going to see these kinds of variable, basically categorical variable, most of the time we are going to use mode because that is the best prediction we can have. Now let's talk about advantages and disadvantages of the 3M technique. So first we are going to talk about advantages. So the technique is very simple to apply and it can be implemented during model deployment. Next thing is that this technique does not require data manipulation. And when I say data manipulation, that means that it does not affect the data distribution of other variables. Now talking about the disadvantages of this technique, it can change the distribution of the variable, which lead to change in the statistical properties like covariance or standard deviation. This technique cannot be implemented when the data has too many empty values. Another thing is that due to the dynamic nature of the data, we have to keep evaluating the model periodically. So what does it mean? Let's understand it with an example. Suppose you have a data set in which we have a variable called salary. We used mean to impute the missing values in this case. We also know that over the period of time, the mean will change. Obviously, because economy changes, so the salary of a person will change. And this dynamic nature cannot be incorporated in model deployment. Hence, we will have to evaluate model periodically. So that's all about 3M technique. In the next video, we will talk about the implementation of this technique. So that's all for this video, and if you are new to this channel, please do like and subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, stay safe and wear a mask.